How the F-35 manages detection, radar stealth versus thermal performance. The illusion of invisibility. In the world of advanced aeronautics, invisibility is a common term, but a technical misnomer. No object is truly invisible to all forms of detection. Instead, modern aircraft like the F-35 are designed to manage their signatures, the various signals they emit or reflect into the environment. For decades, the primary focus of engineering was the radio frequency spectrum. However, as sensor technology evolves, a new challenge has emerged: thermal performance. Today, we analyze the sophisticated engineering balance between radar stealth and infrared management, and how the F-35 maintains its operational advantage in a multispectral environment. The geometry of radar management. Radar systems operate by emitting electromagnetic pulses and listening for the echo that bounces off an object. To counter this, the F-35 utilizes a two-pronged engineering strategy: geometry and material science. First, the external shape of the aircraft is designed with plan-form alignment. Notice how the leading edge and trailing edge of the wings and tail surfaces are set at identical angles. This ensures that any radar energy not absorbed is deflected away from the source at a precise, non-returning angle. Secondly, the aircraft is coated in advanced radar absorbent materials, or RAM. These specialized polymers are engineered to trap electromagnetic energy and convert it into minute amounts of heat rather than allowing it to reflect. By integrating these systems, the F-35 presents a radar cross-section no larger than a small bird, significantly complicating long-range digital detection. The thermal challenge: thermal performance. While radar is an active detection method, infrared search and track systems are passive. They do not emit signals, they simply observe the heat energy radiated by all objects. In the cold environment of high-altitude flight, a jet engine is a massive thermal contrast. This is where thermal performance becomes critical. Every watt of energy produced by the F-135 engine must be managed. The core of the engine operates at temperatures high enough to melt standard metals. If this heat is not shielded, the aircraft becomes a bright beacon for long-wave infrared sensors, regardless of how stealthy its radar shape might be. Engineers face a difficult trade-off. High thrust requires high heat, but high heat increases the detection range of thermal sensors. Engineering the solution. To manage this thermal signature, the F-35 employs several groundbreaking engineering solutions. One of the most vital is high bypass cooling. Before the hot exhaust leaves the nozzle, it is shrouded by a layer of cooler bypass air. This masks the most intense heat and accelerates the cooling of the exhaust plume as it enters the atmosphere. Additionally, the F-35 uses its fuel as a primary heat sink. Before the fuel reaches the engine, it is circulated through the aircraft's electronics and hydraulic systems to absorb excess thermal energy, effectively recycling heat within the airframe. Furthermore, the design of the S-duct air intakes ensures that the spinning, hot compressor blades of the engine are never in a direct line of sight for incoming sensors. Every curve and every material choice is a calculated move to minimize the thermal footprint while maintaining peak aerodynamic performance. The multispectral future. The F-35 represents the pinnacle of modern signature management. It is a machine designed to operate at the edge of physical limits, balancing the requirements of radar deflection with the necessity of thermal suppression. As detection technology moves further into the multispectral realm, using both radio waves and light energy simultaneously, the role of the aerospace engineer becomes even more complex. The goal is no longer just to be stealthy, but to be digitally integrated and thermally optimized. Thank you for joining us for this technical analysis of modern aviation. If you enjoyed this deep dive into aerospace engineering, consider subscribing for more insights into the machines that define our era.